All right, next we're going to do example 4, where we have a golf ball being hit into the air from like a Top Golf or Cool Springs here. You're hitting the ball into the air from the third level of the driving range. It's 48 feet up off the ground, so that's going to be our start value right there, 48. And we want to know how long it's going to take for that ball to come down and hit the ground, all right? So where the ground level is. One way to do the problem would be to graph it and then see if we can find that intersection point. I'm going to show you a little more challenging method here. I know some of you like the more challenging methods. We're going to go ahead and try to factor this thing and see if we can find the roots once we put this into factored form. I would like you to be able to do this, so follow along here with me. You can check your work using your calculator, but we're going to go ahead and use the factoring method. And you could start by putting your two sets of parentheses here. And then you're starting to think of, what goes here and what goes here and here and here to make all this. But before you get into that, when you have a leading term in front of the t squared or the x squared, you want to see if that leading term happens to be a factor of the other coefficient and the constant that is in the problem. In other words, does negative 16 divide into 32? And does negative 16 divide into 48? And the answer to both of those questions would be yes. So that would end up being our greatest common factor. So I'm going to pull the negative 16 away from the t squared. That negative 16 is known as the GCF, the greatest common factor. And we're going to try to think about what would be here in position A. I already did it for you. B and C. So you want to think of it this way. You're going to take 32t, or 32, and you're going to divide out negative 16, leaving you with negative 2t in the middle there. Notice, negative 16 times negative 2t is positive 32t, so I think I did that correctly. Then you're going to do the same with the 48. It's like you're taking the 48 divided by negative 16, and that should be negative 3. You can always check your greatest common factor process, your factoring, by redistributing it and making sure that you get what you had. And I think it works out. Negative 16t squared minus 2t minus 3. Now, the reason that I did that is now I'd like to factor what's in the blue parentheses into its two parts. I made it a little bit more manageable. Instead of having the 16 there, now I just have to think t times t makes my t squared. And if I do negative 3 and positive 1, that's going to give me the minus 3, which is right there. And if I check my outside and my inside, I get negative 3t and positive 1t, and that results in the minus 2t in the middle. So, if you went ahead and graphed this and looked at where it hit the ground, maybe what you can do is graph this in y1 and this in y2. See how I did on my factoring job there. They should produce the same parabola. Now, you're probably finding positive 3 as your t value, 3 seconds. And the reason that works is right here. Think about the zero product property. T would have to be 3 to make this function equal 0, right? For the height to equal 0, the time would have to be 3 because 3 minus 3 is 0. Turns out the other solution to the problem would be negative 1. But negative 1 seconds really doesn't make sense in terms of the context of this problem because the ball wouldn't go negative 1 seconds in the air. So we throw an answer like that away. Only 3 seconds makes sense as our answer to this example. You're going to have a similar problem here for try it 4. So go ahead and do that one now, and we'll review it later in the week.